number one, we're finding if f is power 2, what is cosine of x? So basically we just find the derivative of cosine first, which is what I did wrong. I didn't find the derivative. So which is negative sign, and then plug in power 2 as of x, and so negative sign power 2 will give you negative 1. And for number 2, if we plug in, we find the derivative of 10, which is secant squared x. So we plug in 0 for our x, and so secant of 0 is 1, and we square all of that, so 1 squared will give you 1. And then for number 3, we find the derivative of cosecant x. So first which is negative cosecant x cotangent. So where we have x, we plug in pi over 3. So negative cosecant pi over 3, cotangent pi over 3. Cosecant is the opposite of sine, and sine pi over 3 is negative square root 3 over 2. So we'll switch that, and it will become negative 2 square root over 3 times the cotangent pi over 3 is 1 over pi over 3. So that will just give us negative 2 over 3 as the answer.
3.
So for number 5, we are asked to find the first and second derivative. So the first thing we are going to do is get the numerator. We're going to make this into a regular exponent. So 3 of x will change into x over 1/3. So we have x 1/3 over 4 plus 3x minus 2. And so we're asked to find the derivative. So this is the use the power rule for this. So we have 1/3 x, 1/3 minus 1 will give you negative 2/3 over 4 plus negative 2 times 3 is 6x to the negative 3rd. So now we do 1. You can just put the 3 in the denominator. So I have 1 over 3 x to the negative 2/3 times that by the 4 minus 6x to the negative 3. 3 times 4 gives you 12. So we have x 2/3 over 12 minus 6x to the negative 3rd. So that would be our first derivative. Now we're asked to find the second derivative. So using this, we have x to the negative 2/3 over 12 minus 6x to the negative 3rd. So just like we did for that, the power rule, we do negative 2/3 times the 12 x. Negative 2 minus 3 is negative. Over 3 minus negative 3 times a negative 6 to give you a positive 18x to the negative 4. So 3 times 2, 3 times 2 will give you, 3 times 12, my bad. 36. So we could simplify 2 and 36 to give you 18, 1 over 18. So our final answer will be x to the negative 5 thirds over 18 plus 18x to the negative 4. So that's our second derivative. So with number 7, we're finding the derivative of this function 2x to the 4 plus x squared over 6 minus 7 all to the negative 4. So with everything, I did everything right until I got to this step. The derivative of 7 is just 0, so you have to remember to put the 0 in, and the derivative of x squared over 6 is 2x over 6, but you have to simplify the 2 and the 6, which will give you 1 over 3. So your final, this part of the answer will be 8x third plus 1x over 3. So for number 8, we're asked to find the derivative of the square root of 2 plus 4e to the 4x. So first we have to take this radical, take this function out of the radical. So to do that, we square it by 1/2. So with this, we know that we have the chain rule now. So we bring the 1/2 down. So 1/2 times 2 plus 4e to the 4x. 1/2 minus 1 gives us negative 1/2 times the derivative of whatever is in our parentheses. So we just bring this down, we do nothing to this side. The derivative of 2 plus 4e to the 4x is 4e to the 4x times 4, because we know that the derivative of 2 is just 0. 4e to the 4x, well, e to the x is itself, but since we have the 4, then we know that we have to do the chain rule again. So that gives us this. Then with this we do 4 times 1/2, which gives us 2. So we have 2 times 2 plus 4e to the 4x to the negative 1/2. Bring that down, 4e to the 4x. Now we have 4. Now we can multiply this 4 with this 2, which gives us 8. So now we have 8 times 2 plus 4e to the 4x to the negative 1/2 times e to the 4x, and that will be our final answer. For number 9, we're asked to find the derivative of natural log sine x minus 3. So we know that this by itself is 1 over x, but since we have sine x minus 3, we will do 1 over sine x minus 3 times the derivative of sine x minus 3. So for this, we bring this down, sine x minus 3, and the derivative of sine x is cosine x, and the derivative of 3 is just 0. So we have cosine x, and so now we just multiply this with the 1, and then give it. So when we multiply the cosine with the 1, it just gives us cosine x all over sine x minus 3. And that's our answer.
3.
Okay, so for number 10, we're trying to find the derivative of this function. So the first thing we're going to do is find the derivative of both sides. So the derivative of 1 5 e to the 5x plus the derivative of 1/3 cosine 3x. So now, since there's a 5 with this x, we know, since x is not by itself, we know that we have to use the chain rule. So we do 5 times 1 to the 5 to the 5. The derivative of 1/3 of cotangent 3 to the x. So cotangent, the derivative of cotangent is negative cosecant squared x, and the derivative of 3x is just 3. So put those in parentheses. So now we have 5 times 1/5, which gives us just 1 if we times that by each other. So, yeah. And then 3 times 1/3, which just gives us 1 if we times it by each other. And a negative times a positive, that gives us a negative. So we change this sign to a minus. We have cosecant squared x. Our final answer. So for number 11, we're asked to find the derivative of this function. So first, we know that since we have a 5 in the denominator, we have to move it to the top by changing this positive to a negative. So that'll give us 2x to the negative 6. And this, we're going to act as if this is a 1 in the denominator, so that'll just give us minus x to the negative 1. So now we have to find the derivative of each one, so this will give us negative 10x to the negative 6 minus 11x plus the derivative of 4 is just 0, so cosecant times 0 will just give you 0. Negative and a negative, so we're going to act like this is a 1, so that'll make this a positive, and we can have x to the negative 2, because negative 1 minus 1 is a negative 2. So then our final answer is negative 10x to the negative 6 minus 11x plus x to the negative square, negative 2. So for number 12, we're trying to find the equation of the line tangent to the graph of 1/1x at the point 1, 1/2. So the first thing we know to do is write our equation for finding the line, which is y minus y1 equals m times x minus x1. So now we find the derivative of this function, so we can use the quotient rule, which says bottom. So for number 12, we're asked to find the equation of a line. So with that, we know the first thing we have to do is write the equation to finding the line, which is y minus y1 equals m times x minus x1. So first we're going to find the derivative of this this function, so which we can use the quotient rule. So the quotient rule tells us that we do the bottom times the top minus the top times the derivative of the bottom, the derivative of the top. And then we do it all over the bottom square, which is 1 plus x squared. So with this, we just bring down the 1 plus x. The derivative of 1 is just 0. Minus 1, we bring down the 1, times the derivative of 1 plus x, which will just give us 1, because the derivative of 1 is 0 and the derivative of x is 1. So that we'll just be left with 1 all over 1 plus x squared. So now 0 times 1 plus x will just give us 0. And 1 times 1, that just gives us minus 1, negative 1, times a negative 1 times the positive 1 give us a negative 1. And for the x, we're going to plug in the value that we have up here. So we know that our x value is 1, so we do 1 plus 1, which gives us 2. So 2 squared equals 4. And 0 minus, so 0 minus a negative 1 gives us negative 1 over 4. So we know that this is our slope. So then we plug this plus our points to the equation. So we have y minus y1, which is 1/2, equals our slope. So negative 1/4 times x minus 1. So we first are going to distribute this negative 1/4 to the x minus 1. So that's going to give us negative 1/4 x minus, plus 1/4. So negative 1/4 times the negative 1 gives us a positive 1/4. Then we try to get our y by itself, so we're going to plus 1/2 on both sides. So we're left with y equals negative 1/4 x plus